All right, guys. Good evening. A very good evening to all of you. I can see in the chat that some of the students have joined early and they were waiting here. And thank you for that. Thank you for your patience. Now, on this screen, you can see a question. That's a welcome question for you guys. I want you to read that question and hit the answers in the chat. Just give the answers in the chat. I'm there, and in a short while, you will be able to see me also. So as of now, you can just start giving me the answer to this question that you can see on the screen. All right. Meanwhile, we'll wait for a few more seconds before I turn to the next slide or before I show up my face to you guys. So just start giving me the answers, guys. I'm waiting for your answers. There's a lag of 3-4 seconds. So once you give me the answer, it will take around 3 to 4 seconds to reach me. So come on, guys. I'm waiting for it. Yes. Hit the buttons, guys. I know you know the answer to this question. Just hit the button, guys. Hit the button, guys. I'm waiting for your answer. And meanwhile, I'll just hello Satakshi, hello Rahul, hello Mohit, hello Adarsh, hello Vishwa. Okay, Arun says action probably. Mukesh says action. That's fine. That's great. Come on, guys. Adarsh says okay. Adarsh says hi to Satakshi. Nice. Satakshi says action. Okay, Sukirt says both simultaneously. All right. Now I'll end the suspense now, and I'll just show my face to you guys now. I'll just show my face first. Okay. So I believe you are able to see me now. And hi guys. A very good evening to all of you again. And we'll return back to the answer of this question. First, let me introduce myself for those who are watching my class for the first time. My name is Vikas Agarwal, and I have done BTech in Aerospace Engineering from IIT Kharagpur. And my graduation was done in the year 2008, and since then I have been teaching for IIT JEE. And I have taught for NEET batches also, but primarily I have taught for JEE. And that's about me. I have taught in institutes such as FITGI, Career Point, Bansal Classes, Resonance, and recently I have joined Vedantu. So that's about me. That you all can like, this is what I can share with you, and other things. For that, you'll have to like talk to me. You'll have to get in touch with me if you want to know anything else about me. All right. So let's come to this question now. Okay. I'll be showing the screen now. So you are now able to see the screen, and let's come to this question. So in Newton's third law, which acts first, the action or the reaction? And the answer is they both act simultaneously. The action and the reaction, they both act simultaneously. In fact, in an action-reaction pair, none of the forces preferred. We can choose to call anyone as action, and we can choose to call anyone as the reaction. That is our choice. So till the time I was having a look at the answers, Sukirt was the one who answered it correctly, and some of you also answered it, but probably not correct. Yeah, Sukirt, good evening. I'm still having a look at the chats. All right. So yeah, that's about this question. Now let's focus on this session, guys. So what does this session has in store for you? So guys, this session I'm just going to bring forth few points for you guys, which will just enable you to understand how you have prepared in your 11th standard. Like, this session is primarily aimed for students who are moving from 11th to 12th standard, and it is primarily aimed at giving you a glimpse of how we teach at Vedantu and what we teach at Vedantu. And in this short time that I'll be spending with you, I've tried to highlight some basic points that you may be aware of, or many of you may not be aware of. In my teaching experience, I've seen that people often do complete their 11th standard and still they are missing some basic concepts of a chapter such as laws of motion. So since laws of motion is a chapter that is very basic to your studies, which will find its application in almost each and every other chapter, that's why I've picked up some basic things from that chapter, and we are going to have a discussion on that. The primary aim of this session is to have fun, like, guys. All right, we'll be having fun, and at the same time, maybe I'll be teaching you a thing or two if you don't know that already. So that's the whole idea of this session. So I think we should get started already. So many of you faltered at this question already, I can see that. So that's a very basic thing. You know, Newton's third law is such a basic law. Why I call it a basic law? Not because it's used by us primarily everywhere. Like I call it a basic law because every student who has like taken up science anywhere, like in at any stage, if a person has studied science, I think he has studied this law, and whatever little thing he can remember about science, after he is done with his studies, he has, let's say, moved on to another stream such as commerce or anything else. This is the law that he remembers, all like anybody remembers, like any person in your family, friend group, you find a person who has been in touch with science and now he's not in touch with science. You just ask him Newton's third law, probably he'll be able to tell you this law. So this is such a basic law, and yet people falter on this. So action and reaction, they always act together, and none of the forces is preferred. We can choose to call anyone as action and anyone as the reaction. All right, let's get started now. So how are you feeling, guys? Okay, I can see some more students have joined. Yeah, okay, let me address some queries that I can see on the chat. JEE is asking me, am I taking JEE long-term batch? Yes, Rahul, I'm taking JEE batch. Gaurav says, okay, Gaurav, that's something that I have to address in person. Okay. All right. Pratyush says, Anand sir is also taking class. Well, I'm not aware of that, guys. Okay. All right. Adarsh, I wish you all the best from my side. Tomorrow is your JEE exam. I wish you all the best. May you do that exam with like great competence, and you are able to you pass that exam with flying colors, and you secure a very good rank, a very good percentile. Is that what I can pray for you? All right. Yeah. Thank you, Satakshi. Thank you for comment. That was so nice of you. Thank you so much. It really encourages me to do better in life. Okay. So this was the question that we addressed, so we can just avoid this question now. This is about my introduction, so I think we should move to the next slide. Okay, now in the next slide I'm bringing something again which is related to Newton's third law, and which is again very basic. Let's just have a look at it, guys. Let's have some fun. Let's just see what we have learned in 11th standard and how well we know that thing. Okay, so you can see a block. Just have a look at this figure, guys. This one you can see on your screen. A block is lying on a table and vacuum is there, air is not present. All right, a block of mass kept on a smooth horizontal surface. So the block is at rest, and here I have drawn the FBD of the block. I hope you can see this, guys. So here is an FBD of the block, and I've drawn two forces on the block, the normal and the mg. I hope you all agree with me that these are the two forces that will be acting on the block, and the block is at rest, so n will balance out mg is what I believe. All right, now I want to know which force serves as the reaction of mg. Come on, guys, start giving your replies. I'm waiting at the chat. Which force serves as the reaction? So Sukirt says N. Okay, let me have some other responses too. I'm waiting. When you see my face turned by right angles, turned at right angles towards right, that's the time when I'm reading your chats. So Sukit says N. Let me have other response too. Yeah, there are many people watching this, so why don't we have more response? Pratyush says normal. Sakshi says normal. That's amazing. That's so amazing. Yes. Okay. Can we have more replies? Adarsh says normal. Okay. Gaurav says normal. Creative DIY says normal. Okay. You guys, there are more than 50 persons watching this right now, so let's have some answers. Okay. Mohit Sai says gravitational force is equals to N. So I believe you also wants to say that normal force is the reaction. Mukesh says normal reaction. All right, I think, okay, Palepu says gravitational force. Okay, Palepu has a different answer, so I'll comment on that. Arun says N. Okay, there may be more answers coming there, but I think because of lag, I have received answers a little bit late. All right. So let's focus on this, guys. So many of you have said normal is the reaction of mg. Now, instead of answering this question, let me ask you another question and try to answer this one. Probably this will serve as a hint to this question. All right. So I'm asking you another question. Guys, do action and reaction pair act on the same body? Answer this one. This one is not written on the slide. This is something that I'm asking you guys. Do action and reaction pair act on the same body is my question to you, and that's a hint to this question too. Do action and reaction pair act on same body? Sukir says no. Chinmay says why? Chinmay says yes. Okay, Chinmay says yes. Action and reaction pair. Okay. Pratyush says no. All right. So guys who are saying no, you can just revisit your answer of the question that is present on the screen. I asked which force serves as the reaction of mg, and many of you replied N, and many of you say that action and reaction don't act on the same body. So are you not contradicting yourself? People who said that N is the reaction of Mg, and then who are saying that action and reaction don't act on the same body, don't you think, guys, that you are contradicting yourself? Yeah. So if guys who are saying that action and reaction don't act same body, that is correct. Action and reaction, they never act on the same body. And in this FBD, N and Mg, they are certainly not. They are certainly not the action reaction pair, because a simple check is that they are acting on the same body, so they can't be the action reaction pair. All right. So where is the reaction of this Mg? So to know this, to identify where is the reaction of this Mg, you need to think. You need to think who is exerting this Mg, guys. You need to think about who is exerting this Mg. So Earth is exerting this Mg. All right. For example, you just think of this. Let's say we pull this block, we pull this table aside suddenly. You know, somebody was standing here. He pulled the table aside. So block will start falling down. So Mg will still be there on the block, but normal will not be there. All right. So Mg is still non-zero, but normal becomes zero. So this is another logic of proving that Mg can't be the normal. Mg can't be the reaction of normal. So where does the reaction of Mg acts? We can say it acts on Earth. Earth pulls us by a force which we call as our weight, and at the same time we are also pulling Earth by the same force. So that's what Newton's third law says. So if we now come into this thing, where is the reaction of this N? So the reaction of this N is exerted on the table. Like if this is the table, so the reaction of N is acting on the table. So guys, does this help? Does this help you clear out some basic concept of that you have studied in 11th standard? Newton's third law is such a simple statement, and yet it has got so many things hidden in it. You know, I'm really fascinated by Newton's third law. It's such a simple statement, but you know, there's a lot of things hidden in it. For example, you can help yourself by remembering that action and reaction pair, they never act on the same body. They always act simultaneously. They always act at the same time. And if A exerts a force on B, B will exert a force on A, and this is going to be called the action and the reaction pair. For example, the block was being exerted a force of Mg by Earth. So block is also exerting force of same magnitude in opposite direction on Earth. All right. So these 3 points you can remember. They act at same time, they never act on the same body, and if A exerts a force on B, B will exert a force on A. And fourthly, another point which is very helpful, especially while we want to calculate the torques. Okay, the line of action for both the forces is always same. They always act on the same line. This is another aspect which is very helpful while we are dealing with questions related to torque. All right. So I believe I have I'm able to clarify some of your concepts that you have studied in 11th standard that should have been clarified at the time you were taught Newton's third law. But as I've seen, many of the students, I always caught them unaware regarding these small things. All right. So having said that, let's just have a look at few more situations, few more questions that are very basic, and yet you may just find that you never thought about that. And even if you thought about that, probably you may not know the correct answer. So let's just have a look at another situation. So are you ready, guys? Are you ready? We are moving from the Newton's third law. Now we are moving to another aspect, which again you may find tricky. And I would love... Yeah, okay. Let me just have a look at the reactions. Guys, one request I have. You just keep typing on the chat something to let me know that how are you liking my session, or if you are not liking it at all, do let me know that also, because that will really help me to take the session forward in an appropriate manner, in a manner that will suit you. All right. Okay, Adarsh says nice explanation. Thank you. Gaurav says something about please tell me, which I don't know what he's asking. Probably is okay. When, sir? Gaurav, I think you are referring to some long chat, so I'm not able to. Pratyush says awesome. Okay. Yeah, MGX downloaded normal. Is it obvious? Okay, Chinmay. See, Chinmay has a doubt. Chinmay says, yeah, see, any force, if two forces are equal and opposite, we can't just start calling them action and reaction. No, like action and reaction are always equal in magnitude and they are opposite in direction. But any two forces which are equal in magnitude and opposite direction, we can't call them action reaction pair. It's not the other way around. Like the converse is not true. All right, if a pair, if a force and if two forces they form action and reaction pair, then they will be equal in magnitude, they will act in opposite direction. But you choose any two forces randomly, and if you find that they have the same magnitude and opposite direction, you start calling them action and reaction pair. No, you're wrong. You shouldn't do that. All right, so having said that, we are running short on time, so let's just move to other things that I've brought for you. I have cooked some recipes, some concepts of laws of motion, and I've come to present that before you. So just let's have a look at this, guys. I hope you all are aware of Atwood's machine, and if some of you don't know this, probably you just don't know the name, but I'm very sure that you have seen the structure. Like we have a pulley which is suspended like this, and here is a block of some mass, here is another block of some mass. Let's say we are having a heavier block here and a lighter block here. All right, so this arrangement is called an Atwood's machine, the simplest of arrangement when you start studying about block and pulley system. All right, so while we study Atwood's machine, there are a few assumptions that we consider, and those assumptions are string is inextensible, all right, which says that string cannot extend, and because of which we can claim that if this moves by some distance x in some time, let's say, then this is bound to move up by the same distance in the same times, which mathematically means that if this will have an acceleration a in downward direction, then this will have an acceleration a in upward direction. How can we claim that the two will have same magnitude of acceleration? Because the string is inextensible. You start using an extensible string such as the elastic, all right, elastic that we have in our pajamas. You start using that, and we may have different acceleration of the two blocks. All right, so string is extensible, that's why we consider the acceleration same. Pulley is massless and pulley is smooth. These conditions are invariably mentioned with the Atwood's machine. All right, so now what I'm going to do, guys, I'm going to show you two animation, two gifs. You need to notice them carefully, and you need to figure out the difference between the two. Okay, the difference is a subtle one, so be careful in noticing what is happening. One of them applies to the case that is written on the screen right now. Okay, one of the case suits these assumptions and the other not. Like if these assumptions are valid, let's say, then one of the system will be applicable to this arrangement, to these conditions, and the other will be not. So ready, guys? I'm going to click on the slide, and you will just find two animations there. So be alert, guys. Here we go. Just notice the motion, guys. Just notice the motion. You have to let me know which one is better. Okay, let's say the first one is A, let's say the second one is B. So you have to tell me which one applies to the conditions that I have written. Which one, guys? Let me see your answers, guys. I'm waiting for your answers, guys. Okay, I think Gaurav is having some kind of an issue. So Gaurav, can you just let me know what that issue is? Now, like your messages have gone up, so I may not be able to see them. So you can just post it again. Okay, Palepu, Utkarsh, Chinmay, Sukirt, Adarsh, Anuj, Pratyush, Sanjay, Satakshi, you all say that A figure is correct, and you are absolutely right. In this, pulley is not rotating, and in this pulley I start rotating. So if the pulley is smooth, then it will not rotate. Okay, so this figure doesn't apply with the assumptions that we have taken. But practically, most of the students imagine this situation, like although they are studying this, but they keep on imagining this one, because practically this figure is more like the one that is visible in everyday life. All right, so yes, you are correct. A figure is right. Okay, great. Thank you, Chinmay. Okay, Mohit Rahul says B, and Rahul has changed his answer to A. Okay, all right. Okay, guys. Okay, so let's move to the next slide. Let's see what the next slide has stored in you. Okay, so is this expression for acceleration right or wrong, guys? Since Atwood's machine is a very common arrangement, I hope you know the answer to this. Is this right or wrong? Is this one right or is this one wrong? Chinmay is asking which batch I'm taking. Yes, Chinmay, I'm taking the topper batch. Yes. Okay, Sukhir says right, Palepu says right. Yes, and indeed this is right. Since we are running short of time, so I'll give you a little less time now to answer. Okay, so yes, this expression is indeed right. Okay, now let's just go a step further. I'm changing the conditions, right? Now again have a look. These are not the same conditions as we were having before. Like the string is no more, like the string is still extensible, so that is same. This one is same. Pulley is still massless, but this time pulley and string are both rough. So this time both are rough. So again, you need to figure out, you need to pick up the which of the two arrangements is correct. You need to figure out which of the two arrangements is correct. Yes, Pratyush, Sankalp is the topper batch. Yes. Okay, Rahul was asking me why pulley was not moving. Rahul, if the string and pulley they are both smooth, then string will slip over the pulley. It will not be able to exert any friction on the pulley, and it is friction which causes the pulley to rotate. Like in this situation, currently is a situation that you can see on the screen. You should try to figure out which figure will be applicable. And yes, many of you have got it correct. Many of you have already replied, and you have got it absolutely correct, guys. B is correct. Yes, this time since I gave the string and the pulley to be rough, so this figure will apply. Okay. Having said that, let's go back to the assumptions once again. I want to show you the assumptions, guys. So these are the assumptions, and I'll be now giving an expression for acceleration. You have to tell me whether that expression applies or not. Okay, so how about this, guys? The same expression that we have written earlier, is this expression still valid? Let me know, guys. Is this expression still valid? Come on, guys. Yeah, I know there is a lag, so I'm waiting, but I'm waiting. It's around 5 to 6 seconds, not more than that. So Arjun says no, Satakshi says no, Palepu says no, Chinmay says no. Okay, Mukesh says no, Adarsh says no, Adarsh says no 2 times. Okay, Utkarsh says no, Mohit says no. Okay. Well, all right. I think that's our I've received many answers. So guys, I would say that this expression is still valid. And now let's discuss why is it this valid, guys. This is valid because the pulley is massless. So pulley has got zero moment of inertia. Okay, zero moment of inertia. So no effort goes in rotating the pulley. If something has got zero moment of inertia, absolutely no effort will be required in rotating it. So this time pulley will rotate. So this figure is correct, but it is not going to affect the expression for acceleration at all. All right, what will happen? The tensions on the two sides of the string will still be equal. Okay, although there is friction, but the tensions will still be equal. So nothing will happen. Okay, Gaurav, I request the teacher to give 5 minutes at last moment. Okay, Gaurav, I'll specifically deal with you for 5 minutes. All right, I'll specifically deal with you before I end this session. I'll specifically deal with what. Why aren't you taking classes now? Okay. There's Pratyush. There's something related to. Okay, Pratyush. See, I can't decide what batch says I'm taking. You know, that's out of my jurisdiction. I take batches what I'm allotted. So that's about your query. And let's come back to this, guys. Let's enjoy this one first. We can have those discussions. Okay, so you got this one. All those guys who said no, I want you to be clear on this, that if a pulley is given to be rough but it is still massless, then it will have no impact on acceleration, just that the pulley will start rotating. All right. Okay, so all right, if this thing is clear to you, let me again change the conditions. So this time the pulley is heavy, this time the pulley and string are rough. So again, I want you guys to first figure out which figure is applicable, which case is applicable. So you can just, yeah, hi Chinmay. Yes Chinmay, I enjoyed that time very much. You know, I love teaching you guys in bridge course, and I miss you too, guys. I miss you too. I myself love teaching you guys. Okay, yeah. So since the pulley is rough, the string is rough, this figure will be applicable. Having said so, let's just see, is this one right or wrong, guys? Now let me know if this one, I think you already know the answer now. If after 2 questions, if you still not give me the correct answer, then that would not be justified, guys. Please, come on, give me the correct answer now. So is this expression right or wrong? Yes, it is wrong. Yes. Now you people are responding. So yes, it is wrong. It will not be like this. Okay, just yes. Now just tell me, will the actual acceleration less than this value? So first, or the actual acceleration will be more than this value. Now choose this one. This one was not present in the slide. I have written it right now. It's a question that popped up in my mind right now. So let me know this, guys. Let me know this. Yes, yes. Sukrit is right. Pratyush is right. Probably more answers are coming, but I'm waiting a little less now because I have few more things and time is running out. Okay, so yes, the acceleration will be less because now some more effort will be required to rotate the pulley, and if you do some calculations, the correct expression would be m2 minus m1 upon m1 plus m2 plus moment of inertia of pulley by r square. So that will be the expression. If you want, you can remember also this expression, because Atwood's machine is such a common case, such a simple case, that you may just find its application anywhere, and it will help you a lot if you remember the acceleration, the expression for acceleration. And if you remember this expression, it will further help you because it takes care of both the situation. In situations where pulley is not rotating or when pulley is light, you can simply ignore the contribution of pulley, and when it is heavy and when it is also rotating because of friction, you can consider this acceleration. All right. Okay. R. Okay, Mohit, R is the radius of the pulley here. R is the radius of the pulley, and I is the moment of inertia of the pulley about its own axis, the axis about which the pulley is rotating. Okay, so let's move ahead, guys. I'm going to present another very common question in front of you, and I believe you would have all solved that question, you know, especially if you were in any coaching institute for that matter. That's such a common question that everybody makes student do that question. So let's have a look at this question. So right now what we can see on the screen, there is a wedge and there is a block on that wedge, and friction is absent everywhere. No air is there. These things are not written on the slide. I am telling you, friction is not present anywhere, and we want to accelerate this wedge with some acceleration, and our aim is that the block should remain stationary. This block should remain stationary on the wedge. So that is our aim, and what acceleration is required for that? I'm giving you options. You need to pick one. Pick one, guys. I think you should have done this question, and you should be knowing the result too, because again, this is a very common situation, so it always helps to remember the result for common cases. So, and if you have not done this, if you don't know the result, stay relaxed, nothing happens, you know. We'll see how to solve this one. Okay, yes, so I'm already getting the replies. Arjun probably gave the reply even before I presented the option, because he did not give me the reply in terms of options. He just mentioned the answer, which is great, and I think you all guys can see that in the chat yourself. So Arjun has told me the answer. Pratyush says A, Palepu says A, Jagriti A. Okay, hi Jagriti. Mukesh says G tan theta. Satakshi says G sin theta. No, Satakshi, G sin theta will not be correct. G sin theta will not be correct, Satakshi. Okay, so many of you have already replied A, so I believe you know this to answer to this one. A is indeed the correct answer. For those who did not get it correct or who haven't done this question before, what you have to do, you can just assume that this wedge is moving with some acceleration A, and now you can think on these lines, that if a guy or if an observer is sitting on wedge, he will say that the wedge is at rest, or so the block is at rest. He will say that the wedge is at rest, and if the block is not moving on the wedge, then he will say that the block is also at rest. So according to this guy, the forces should balance. Now he will draw a normal, he will draw 1 mg, and since he is himself accelerated, he is sitting on the wedge, so he will also draw a pseudo force. Alright, so we balance these three forces. We use the condition of equilibrium. According to this man says the block is in equilibrium. So according to this man, the block is in equilibrium. I've just killed that man. I have just painted him blue. Okay, so so we balance the forces, we get the result. Okay, so now I'm going to extend this one. I'm going to extend this one, this question. Just have a look at this one, guys. Now I'm not asking you the acceleration. I'm asking you how much force one should apply. How much force one should apply so that how much force one should apply so that the block can remain at rest relative to wedge. And here are your options, guys. Pick one. Here are your options. Quickly pick one. Okay, Chinmay Sharma is asking somebody. Okay, Chinmay Sharma. That's not a very like that's a message I don't want to see too often. Diagram again. Okay, diagram again, guys. You need diagram again. Okay, here's the diagram. Just I have added a force to the previous diagram. That's it. Instead of talking in terms of acceleration, I am now talking in terms of force. How much force should be exerted so that block remains stationary on the wedge? That is what I'm saying. Okay, let me see the answers, guys. Palepu says A. Okay, Palepu. Mohit says A. Sukirt says A. Okay, Gaurav says A. Adarsh says A. Arjun says A. Okay, alright, that's enough, guys. I think you all have got it correct. Because what logic we can give, let's say we already know the acceleration that we need. The acceleration is g tan theta, and let's say if the block is not moving on the wedge, we can treat them as one unit, and so this one unit is moving with acceleration g tan theta. So F equal to mass into acceleration. Mass would be taken as the total mass of the unit. So that should be the answer. All right. Okay. Yes. Great. Okay. I'm further modifying this question. My last modification for today. Okay. Now what I'm doing, instead of exerting the force from here, I'm not exerting the force from here. Instead, I have just hung a block from the wedge. I have suspended a block from the wedge. So this block is responsible for accelerating the wedge. So how much mass should this block have? Okay, this yellow block, इसका मास क्या रखे? इसका मास मैं कुछ x मान लेता हूँ, ठीक है? इसका मास क्या रखें जिससे कि ब्लॉक वेज पे मूव ना करे जब सिस्टम को हम रिलीज कर दे? When we, okay, I'm repeating the question in English. Probably some of you may not be knowing Hindi. So the question is, the block that I've suspended from the wedge, how much mass should this block have so that this block, the blue block, can remain at rest relative to the green wedge? Okay. So here are your options. Go ahead, guys. Go ahead. Okay, I'll show you the figure once again. I think my face was covering the figure. So here is the figure again. Here is the figure. And now we go to the option. Okay, now you are able to see the complete figure. I'm sorry for blocking your figure by my face. Okay, so now you have the option. Okay, many of you say B, and I've caught you guys. I've caught you. You know, I caught you off guard. This is not the correct one. I'll tell you why. Okay, let's say, see, we were supposed to exert a force of m plus mg tan theta. Now, probably you're thinking on this line that if we choose the mass as m plus m into tan theta, so it is going to exert a force of mg, that means x into g. Alright, so you need to understand here that, guys, if this tension becomes equal to this one, how will this block move? And if this block will not move, how will the wedge move? So just let me know if you got that one, guys. हमें जितना फोर्स चाहिए, हम अगर उतने ही वेट का ब्लॉक लटका देंगे तो उतना फोर्स जनरेट नहीं होगा. Alright, my point is, if we need some amount of force, suspending that much, a block of that much weight will not do the job, because if that block is moving, then obviously the tension is less than the weight. So this is a catch, guys. This is something very tricky. You know, this is something very tricky. Like this is again a point that many of the students miss, that suspending a block of mass m may not always create tension mg. Remember this one, guys. This is a point where many of the students commit mistake, and many of your problems in laws of motion went wrong while you practiced that for the first time, because you missed this point and you are still missing that point. Many of you answered B, but B was just a tricky option. It was there for the students to pick because it was incorrect. All right, so you need to understand this. You need to remember this statement. I'm giving a statement, you just remember that statement. I'm very sure it is going to help you in long run. A block of mass mg may not always, a block of weight mg may not always create a tension of mg. It can create a tension of mg when it is at rest, when it is not moving. If it is accelerating downward, tension will be less than mg. If it's accelerating upward, tension will be more than mg. I know that you all know this thing, but when it is required to, like, we falter at times because we don't look at the situation in this manner. Like, you have always considered, seen pulley block arrangements, and you have seen the block moving, and then you have concluded that the tension should be more than mg or should be less than mg. But never ever have you thought like this, that if we want to apply a force of, let's say, 100 Newton by hanging a block, then the weight that should be hung should be more than 100 Newton. All right. So I think okay, and I think you are getting the answer now. Okay, Satakshi, this was one of the explanation that I gave. I'll just repeat this one again. What I said, if we are hanging this much mass, okay, so the downward weight, the downward force on the block will be m plus m into g tan theta. Okay, and if the tension also becomes equal to this, remember that we need the tension. I'll go back to the figure. We need this force. To be m plus m into g tan theta. All right. So if the tension is also this much and we suspended the same weight, then how will this block move? And if this block will not move, how will the wedge move? So there is a contradiction here. If we assume that we have suspended m plus m tan theta, then we reach at a contradiction. So we must suspend more mass. So is this clear to you, Satakshi? Did you get it? I understand that the net force on the block should be equal to the required force. Yes, now how to do this question? If you ask me how to do this one, okay, I'll just use some space. How to do this one? You can do it like this. We knew that the tension should have been m plus m into g tan theta. That much tension we needed. Suppose we suspended a block of mass x. So this is t. This downward force is xg. So we are going to write xg minus t equal to x into g tan theta. Okay, because if this wedge is moving with some acceleration a, which is g tan theta, this block will also go down with the same acceleration. So net force is xg minus t. This is mass and this is acceleration. Have a look, guys. You solve this equation, you get the value of x. So you got this one, guys? Okay, all right, great. It's pretty fine that you all got it. Now I have a question for you. Based on what I have taught you, I am going to pose a practical problem in front of you. All right. Okay. The answer to this question was option A. Okay. So you can just note this option down, because whatever I am going to ask is related to this option. We need to hang this block. Okay. So. Okay, Gaurav, I'll address your issue. Okay, I have just one more slide to show. So, okay, so let's say I have asked you guys to demonstrate this whole scenario in front of me. Okay, let's just consider a practical situation. I have asked you guys to demonstrate this whole situation in front of me, and I am able to provide you with frictionless blocks and frictionless table. Let's say I have given you that. I have given you tables, specially made tables which are frictionless, specially made block and wedge which are frictionless, and I have asked you to demonstrate this to me, but I have given you three wedges. Which one are you going to pick? That is my question. Which wedge are you going to pick to demonstrate whatever we have studied here? Which wedge are you going to pick? Or can we choose any? Can we choose any one, A, B, C? Or can we choose two of them? Or is only one of them applicable, or none of them is applicable? So Sukhirt will choose A, Gaurav will choose A, Adarsh will choose A. Okay, yes, Sukhirt got it correct. Yes, correct, guys. If I just go back to the previous slide, see, if this was the mass of the block that is to be suspended, so it can't be a negative number. So if it can't be a negative number, then tan theta has to be less than 1, which means theta has to be less than 45 degree. So out of the wedges that I have shown here, only one is having an angle of less than 30 degrees. So this one can be used. We cannot demonstrate by using these two wedges. Okay, got this one? Everyone got this one? Got this one? All right, guys. So that's all. That's all the things that I've brought for today's session. What I wanted to highlight here is, guys, there are very basic things that needs to be understood to have a clear or to have clarity of a concept. These are very basic things, and these things should have been covered at whatever place you have studied. And it is your responsibility also to think through, to think deeply on any topic or any subtopic or chapter that has been taught to you. So these are the few things that I brought to you. Now let me address Gaurav's query. He wanted to know how can thank you, Chinmay, thank you so much. Gaurav wants to know yearly plan to work out things. Gaurav, I'll tell you few things, and probably this is helpful to everyone. So guys, just listen to this. You can just give me 5 more minutes of your, so I'll be grateful for that. I'll tell you guys, the plan that you need to have should be a customized plan. Like, there is no plan that I can call as a universal plan, that I give that to each and every one of you, and each and every one of you are able to follow that plan and you are being benefited from the plan. It's not like that. Plan is always a customized one. It is dependent, or it is based on your preferences, your proclivity, how you want to study, and what subject you prefer to study, and what is your mental disposition, how good you are at handling pressure, and how do you feel like if things are left out, if you are not able to achieve your target, how confident do you feel, or how low confident do you feel. So these are all the parameters or all the things that we need to consider when we make a plan. Now, having said that, what can you do in your capacity? See, first of all, the plans will be different for persons who are going to coaching institute, and for people who are planning to just complete their school syllabus as of now, and then planning to study for the next 1 year for examination. So plan is different for those. I believe many of you are already going to coaching institute, because many of the students nowadays, they obviously join some coaching institute. So having said that, what can you do? See, the best thing that you guys can do, let me tell you one thing, that guys who are going to coaching institute, you are always short on time. You are always short of time, because you are spending your time at 2 places. You are spending your time at your school, you are spending your time in coaching institute, and you are spending a lot of your time in traveling also. So you are always short of time, and that is not with only you, that is with everyone. Many times students feel depressed when they say, or when they start feeling that I don't have much time, but that's the case with each and every aspirant. So stay relaxed on that. Each one of you has got only 24 hours in a day. All right, no, not less than that, not more than that. So as far as that the time is concerned, you are all on equal footing. All right, that may not be true with the facilities that you have got to study. Some of you may be privileged enough to study in a better place, and some of you may not be. So that's another aspect. But as far as time is concerned, you all have the same time. So how to make a plan? You are pressed for time, so your plan should always be time efficient, because हमारे पास टाइम कम है, तो हम उसको अच्छे से efficiently spend करना चाहेंगे. ठीक है? So what I would suggest, if you are going to a coaching institute, or you have joined anything such as a platform like Vedantu, which is providing you classes regularly and which is giving you homework regularly, your sole task should be to finish that homework timely, because that's more than enough. If you are able to do that, if anybody is able to do that, whatever homework has been given to you from your coaching institute or from your online course that you are following, from any place that you are following, you need to, your target should be to finish the homework and never pile your work, because once you start keeping your work pending, it will take the shape of a huge pile that will seem never ending. So don't let the work pile up. There will be times that there will be instances when you will not be able to finish today's homework today itself. On that day, what you should do, you should take a decision, and you should start skipping things. Like, what can I do? See, if I know that today I have to attempt around 50 problems, but 2 hours is what I have. All right, so 2 hours may not be enough to have a good attempt at all the 50 problems. If I were you, what I would have started, I would have solved all the odd numbered problems first or all the even numbered problems first, because that way I'm not losing out on the variety of the problems. All right, because if any particular variety will have at least 2 to 3 questions. All right, so if we are attempting all the odd numbered or all the even numbered problems, at least we are covering the variety. And if I'm able to attempt half of the questions and I have time left, then probably I can go to the other set. Like if I've already attempted the even numbered question, then I can go to the odd numbered question. So I can, like, I would not like to attempt first 15 question and then leave the remaining 30-35 question, or for attempt the first 30 and leave the remaining 15-20 question. Instead of that, I would like to go through the entire questions, the entire assignment, by leaving out the alternate one. So that is one thing that you can do. And as far as time schedule is concerned, Gaurav and others, you need to figure out what time suits you best. Like if I can tell it from my own experience that I used to work very efficiently during the night. Like if I am doing some work, if I take around 8 hours to complete some during daytime, like from let's say 2 to 10, I am doing some work. I generally do the same amount of work if I'm sitting for let's say 11 to 3. So I usually I preferred working at night because my efficiency went up. So that is regarding me. So you need to figure out what suits your body clock, how you feel comfortable, and you need to utilize, you need to make your plan, you need to plan your day based on that. So that is what I can see. As far as general attempting is concerned or studying is concerned, see, you should seek help only after giving ample thought on a question. Seeking help again and again is not going to help you. You have to master the art of finding the answer. Knowing the answer will not help. So avoid seeking of help too often. Try to solve the question on your own as much as you can, because that will really boost your confidence also. All right, so I think these statements may just help you. I want to help you guys in any manner that I can. So Gaurav, yes Gaurav, surely we can surely do that. What I'll do, okay Gaurav, okay, I'm writing my number here. I'm not sure whether that's a good thing or not, because this video will stay there in the recordings to be watched, but I'm writing my number on the screen. You can see that, and you can just WhatsApp me and you can let me know if any query you have. Do tell me your name and the session that you have attended, like the date or the time you should mention, so that I'll be able to relate to exactly what I delivered to you. And all right, so you can take my number, you can contact me personally, so individually I can address whatever query I can address. All right, refrain from posting doubts, okay, because I get too many doubts on the WhatsApp, so I'm able to reply to some of them. So I may or may not be able to reply to questions. All right, but if any query regarding planning you have, I'll definitely try to address that one. Okay, so that's all from my side, guys. One last thing I like to bring to your notice a course that we have launched. That's a NEET course, 1 year long course, and it has already started from 25th March. But if you have missed some classes, you can always take the recordings. And if you enroll now or around 2 to 3 hours from now, then you'll be getting this price, which is the lightning price, which is generally offered after a webinar, and this is a webinar that's going on. And otherwise the course price is this much. So you can click on this link, and the link that is mentioned there, I'm not sure whether it's clickable or not. If it's clickable, you can just click on it. If it's not, you can just type it in your address bar and you can get to the course. So what do we offer in this course? First of all, we offer you lectures such as this one that we have just now went through. So we teach like this. We use many graphics, animation to make sure that you guys grasp the concept in a very lucid manner and in the most easy to remember way. So that's one thing. Apart from that, you will get the facility to ask your doubts 24/7. You will be getting assignments after each session, and at the end of the chapter you'll be getting chapter assignments. And fortnightly or probably after every 3 weeks you will be having your tests, the online test that will just keep you updated regarding your how well you are progressing. So, and there are many more benefits, but I'm not able to recall them as of now. So I suggest, if you guys like this class and if you want to study in classes such as this, you can just enroll in this course. with that note, on that note, I bid bye bye to you guys. I'll just have a look at the chat now. I am not having I was not able to see that for quite some time now. So before bidding you guys bye, I would like some kind. Okay, all right, guys. I just like to say bye to you. Okay, bye Mukesh, bye Adarsh, bye Rahul. Okay, that's great, Rahul. You're already there. Okay, bye Adarsh. Good night. Sweet dreams. By Satakshi, by Palepu, all the names that I can remember, I am just addressing them on my own. By Mukesh, by Sukirt. Yeah, it was fun. It was fun, guys. It was a short session, but still, it was very fun. I loved that session. Bye bye. Thank you, guys. Thank you. Bye bye, guys. Yeah, I'm ending the session now. Bye. Thank you, guys. Bye.